Okay, chapter 5. Okay, this chapter is about linear equations inequalities. So chapter 5 covers all the information related to linear, straight line. So function, straight line, equation of the straight line, inequalities, everything related to the linear. And chapter 5.1 is the rectangular coordinate system. So let's learn from this rectangular coordinate system. Okay, in this case, we need two number lines. One is number line x, and the other one is number line y. So why don't I draw a number line, horizontal number line. Okay, this is number line x. Number line x, and another number line. Okay, the other one is a vertical line. So the number line is vertical this time, and let's say this is the y. Okay, number line y. So two lines. In this case, two lines form a plane. This is a plane, right? Plane. This is flat surface because there are two lines, and then these two lines will make one surface. So that is a plane, and we call it coordinate plane. Okay, coordinate plane. Okay, and then the intersection is, we call it just zero. The number line, right? Number line. If there is zero, then as you go right, the number will be positive, right? Positive 1, 2, 3, 4, like this. And as you go left, the number will be negative. The number will be negative, right? Okay, so this is number line. And the vertical number line is same thing. As you go up, then the number will increase. So 1, 2, 3, and so on. As you go down, then the number for this number line y, the y value actually, right? Y value will decrease. Negative 1, negative 2, negative 3, negative 4. Okay, so we call this a rectangular coordinate system. Flat surface using two lines. It's a rectangular coordinate system, and each number line has numbers: positive number, negative number, and 0. Okay, so actually the plane is separated into 4 parts. So we call it a quadrant. So the upper right corner is called quadrant 1. Quadrant 1. And as you go counterclockwise, the upper left corner side is the quadrant 2. Quadrant 2. And the lower left part is the quadrant 4. Quadrant 3, sorry. Quadrant 3, right? 1, 2, 3. And finally, the last part is the quadrant 4. Quadrant 4. Okay. And then there is any point on the plane. So let's say we have a point over here. Let's say we have a point over here. So you can put a point on the plane, and each point has a address. That address is separated into an x value and the y values. So let me write it here, x value and y value. So the address of this point, we will use a parenthesis. And this one will have x value, y value. The x value is this. Starting from the origin, we call this origin. The center is the origin. Okay, this is the origin. Okay, so starting from the origin, count how many units the point is away. So as you go to the right, 1, 2, 3, the x value is 3 units away from the origin. 1, 2, 3. Then the x value of the point is 3. And the y value is, let's start from 0, and then let's count the number of units going up. So in this case, it's going up 1 unit. So the y value is 1. Okay, so this is the address of this point. And the address, okay, each x, so this point, this value is called x coordinate. X coordinate. And the y value is the y coordinate. Okay, so x coordinate, y coordinate. So on a flat surface, there is a point, and each point must have its address. That address is called order pair. Okay, we can write the address in order pair. So this address is an order pair. Order pair. And this order pair has x value and y value. So always x comes first. Always x value comes first. X coordinate comes first. So here it is. Here is the point x and y. X coordinate, y coordinate. And they are within parentheses. So the first number is x coordinate, the second number is y coordinate. Okay, so it's really important that writing the order pair. So let's say what would be the order pair of this point? Let's say this point A, okay, this is point A. Okay, let's say this is point B. Then what is the order pair of this point B? Okay, put parentheses. B is just the name of this point. We use a capital letter to represent name of a point. So the x value is starting from this 0. Let's check how many units is away from the horizontally. So 1, 2, 3, 4. So if you go down, then that is 4 units away from the center. And the value is -4. So x coordinate -4. Then y coordinate is, if you go to the y-axis, then this y value is 1, 2. 2 units away from the center. The origin. So the coordinate of the point B is -4 and 2. Okay, -4 is the x value. Okay, so how about this point? How about this point? Okay, let's do the same thing. Let's say this is a point C. Then the order pair is, okay, if you go up, you are here. So this point is 1, 2 units away from the center to the right. 1, 2 to the right. So the x value is 2. Y value is, how many is going down? Actually from here, 1, 2, 3, right? If you go here, then this is 1, 2, 3. 3 units away, down from the center on the y-axis. So y value is -3, -3. Okay. Okay, how about this? How about this point? Okay, this point is, let's say the name of this point is D. Then the coordinate is, okay, this point is in the center, right? Center origin. The x value is in the origin because, from the origin, you are not moving to the right or left. The number, if you bring it down, the number is in 0, right? 0. So you are not going to the right or left. So the x coordinate is 0. And the y coordinate is 1, 2, 3. As you see this, the y value is 3. Okay. How about, let's try one more. Okay. How about the coordinate of this point? Let's say this is point E. Then even this one's the same thing. If we move it to the center, then what? It's not moving to the right or left, so x value is 0, and y value is 1, 2, -2. So there is a very important concept. If, all the points on the y-axis, we call this, okay, this vertical line is called the y-axis. This is called the y-axis. The vertical line, the vertical number line. And this horizontal number line is called the x-axis. X-axis. So all the numbers on the y-axis has x value equal to 0. All the x values of the points on the y-axis is zeros. Okay. How about this point? This point is on the x-axis. Then the x value is, of course, the x value is -4, right? -4. And then this point is not moving up or down. It stays on 0, right? 0. So y value is always 0. So how about this point? Same thing. How about this point? Okay, this point is, x value is 3. Y value is, if you move this one to the y-axis, then it's 0, right? 0. Okay. So here's another important concept. All these points on the x-axis have the same y value that is equal to 0. So y value is always equal to 0 if a point is on the x-axis. Okay, let me write it here. Points on the x-axis. Points on the x-axis. We don't know what the x value, but y value is always 0. Y value is always 0, right? Okay, points on the y-axis. Y-axis. So y-axis is what? We don't know what the y value is because it depends on the points. So we don't know the y value, but x value is always 0. Right? X value is always 0. Okay, so make a note on this one. Okay, exercise number 1. Okay, graph the order pairs. So there are 1, 2, 3, 4 points are given. So we want to graph this point. Graph means, plot this point. So first we need to draw a horizontal line, which is the x-axis, and a vertical line, the y-axis. Okay, the center is 0. As you go right, it is 1, 2, 3, 4. As you go left, -1, -2, -3. Up is 1, 2, 3. Down is -1, -2, -3. Okay, so let's use a different color. Let's put a red one. Okay, so -2 and -2. This means this is the x-coordinate, x-coordinate. And this is the y-coordinate, y-coordinate. So -2 is 2 units to the left from center. The x value is 2 units left to the center, so we are moving it here. And then y value is -3. So from this one, we go down 3 units. 1, 2, 3 units down. So this is the point. This is the location, the graph of this point. Okay, 3 and -2. The second point is 3 and -2. So go 3 units to the right. So starting from 0, x is +3, so go right 3 units, and then 2 units down. 1, 2 down. Right? So that is 3 to the right and 2 down. So, okay, let me get for the first point. -2 means 2 left, right? 2 left, and what? 3 down. Right? From center. From the origin. Make sense? Okay, 1, 3 is 1 right and 3 up. 1, 2, 3. So this point is this is the graph, location of this point. 4, 2 is move 4 to the right, 1, 2, 3, 4, and then 2 units up. So this is the location of this point. Can you see it? Okay, then let's try the problem number 1. Okay, why don't you try now? I will do mine, you do yours. Okay. All right, so draw a horizontal axis, x, and the vertical axis, y. And then write down x and y so that we know that the horizontal number is x. Its values for the x. Okay, so 0, and we have a 4, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, right? Okay, so -1 and 3 is -1, so move 1 to the left and 3 up. 1, 2, 3. So this is the point, -1 and 3. Okay, 1, 4 is 1 to the right and 4 units up. This one, right? 1, 4. Okay, the next point is -4 and 0. -4 is move 4 units to the left, and then 0. 0 means do not move up or down, right? So y value is 0. That means vertically there's no movement. So put it over here. So this is -4 and 0. Okay, the last one is -2 and 1. -2 and -1. So 2 units to the left, 1, 2, and then 1 unit down. So this point. So this will be -2 and -1. Can you see it? So from the origin, for the first point, from the origin, we will move 1 to the left. So -1 means 1 to the left, and then 3 units up. The second value is up and down. The first value is left or right. Okay, now let's find the coordinate of the point. So here are points A, B, C, D. So the coordinate of A is, okay, in order to get this, let's move horizontally first. Horizontally, so we are moving 1, 2, 3, 4, right? 4 to the left. So this point is over here. This vertically, move this point vertically, then the point will be placed here. So we are moving 1, 2, 3, 4 units to the left. So -4. -4 is the x value. And then we will move 1, 2 down, right? 2 down, so -2. Okay, can you see it? So x value is move the distance from the horizontal distance, away from the zeros, from the origin. Okay, this letter C is, the point C is, okay, we are not moving right or left. We are not moving horizontally. Stay there and then just move down. So horizontal distance is 0, and then we are moving 1, 2, 3 down, so -3. Okay, the point D is this over here, so we are moving from the center horizontally. Move horizontally first, so move 1, 2, 3 to the right, because this one is over here. And then how many units down? 1, 2 down, so -2. So going up is positive, going down is negative. Okay, the point B is over here, so if you bring it down on the x-axis, we are moving 1, 2, 3, 4 units to the right. So right is positive. And then how many units going up? 1, 2, 3, 4 units up. So the y value is, y coordinate is 4. Okay, let's try problem 2. Okay, problem 2, okay, point A. Point A is starting from 0, moving horizontally to the right, 1, 2, 3, 4. So x value is 4. How about the y value? From here, we are moving 1, 2 units up. So y value is 2. Okay, B is what? B, bring it down. Bring this one down on the x-axis. Then what is the x value? -3, right? -3. Bring this one down on the x-axis. Then x is -3. So the x coordinate is -3. And bring this point to the number line y. Then the y value is 4, right? 4. So you can do this way. And C is, okay, this point is on the -3, so y equals -3. And then this point is not moving up or down, so the y value is 0. Remember, the points on the x-axis, all the points on the x-axis have the same y value, which is equal to 0. Okay, this is the center origin. So origin is x equals 0, y equals 0, always, because this point is now moving horizontally, stays, so the x value is 0. And then the point is, this point is not moving vertically, so the y value is 0. So origin is always 0, 0. Okay, exercise number 3. Okay, this exercise contains some data. So, there are 5 patients who took medicines, and the heart rates are, measured. So before taking the medicine, there are 5 heart rates, because there are 5 people. And after taking the medicine, they measure the heart rates, and the data looks like this. So when we graph this data, let's check. The data above is the heart rate before taking the medicine. So x. So we will use x here. When you draw this one, look at this. The numbers are like 80, 85, 75, and 90. The number is very large. So we don't want to start just like, we don't want to start from 0, 1, 2, 3, 4, 5. Then this will go all the way out of the range. So instead of using this, why don't we cut the line? Omit some lines so that it will start like from 70, something like that. So in this case, we don't have a negative heart rate, so we will start from 0. As you go to the right, we will cut the line a little bit, cut the data a little bit. This zig mark means we cut some part of the line and then go straight to the right. So this is x X values, the heart rate before taking the medicine. And as you go up, cut the line and then go all the way up. So this vertical line is this is the heart rate after taking the medicine. So this is before taking the medicine. Y, look at this. Y is after taking the medicine, and X is the before taking the medicine. Okay, and then let's start from here. This is 70, and then 75, 80, 85, and 90. Because the X value is starting from 75 all the way to 90, so we need these values. And then the Y value starts from 70, and then 75, here is 80, 85. Okay, so we have x-axis and y-axis. X-axis is the heart rate before taking the medicine. Okay, we can write it over here. Heart rate before taking the medicine, right? Medicine. And this is beats per second, right? Beats per second. Beats per second. Okay, the y-axis is the heart rate. I think I better use this way. This is the heart rate after medicine. Same as beats per second. Beats per second. Okay, then let's plot the data. Okay, the first data is x is 85. So you go all the way from 0, 85 to the right over here. And then 75. 75 is, okay, this is the first data, right? First data. This is x coordinate. This is the y coordinate. So y value 75, so move up 75 units. So from this 85, 75 is over here. This is 75. Does it make sense? Right, this one. So this is 85 and 75. Okay, 80 and 70. So move 80 on the x-axis is over here, and the 70 is over here, the y value. So 80, 70. Okay, 85 and 70 is, 85 is here, and 70 is here. It overlaps. So why don't I just remove this? Remove this. Let's write a point. Data A, B, C, D, E. So this is A, right? And this is B. And then the C is 85 and 70 is, horizontal value is 80, 85, and the vertical value is 70. This one, right? So this is C. And then D is 75 and 80. So 75 is, X value is 75 over here, and Y value is 80, so move all the way up here. Okay, the last one is 90 and 80. So X value is 90, come over here, and then 80 is move up all the way here. Okay, so we can plot this data, plot the data like this. So we call this a scatter diagram. Okay, scatter diagram is, it shows all the points of the data. Okay, the heart rate, the unit should be beats per minute, not beats per second. So I corrected it, beats per minute. Okay, problem 3 is, okay, when in order to escape from a airplane, okay, let's say the space between seats are in inches, so 6 inches. If the space between 6 inches, then the evacuation time will be 44 seconds. So we have a data. X is the space between seats in inches, and Y is the value of the evacuation time in second. So let's graph a scatter diagram for this data. So first we need to draw the x-axis. The x-axis is starting from like a 6, so why don't we just use one whole? We don't have to cut the cut the number line x, right? Because it's starting from 0, close to 0, right? And then the y-axis is starting from 36. So we better cut the line. So use the cutting line symbol and then go all the way up. Okay, so this is the y value and x value. And then we can start from this. Okay, the x value is 4, 6. So why don't I use, okay, let's use a multiple of 4. So 4, okay, here's 4, 8, 12, 16, and 20. Now instead of using units, we will use a multiple of 4. So let's start the y value. Y value starts from 36. Okay, 36, and then 40. Here 44. Let me put more space. Starting from 36. Here it is 40. Here it is 44. Okay. Maybe. Okay, let's make it more precise. So 36, 38, 40, 42, and 44. Okay. So I used the interval for the x is 4 units, and then the y has interval of 3. Okay, let's plot this point now. Okay, x, let's say this is point A, B, C, D, E. So x is 6 and y is 44. So x is 6, so starting from 0, x is 6 is over here. This is 6, right? And then 44 is going all the way up here. So this is point A. Okay, point B is 10 and 43. X is 10, so it should be over here. 10, this is 10, right? And then go up to 44 up. So 43 up. So 43 is over here. So it's gotta be somewhere between 42 and 44. Right? So let's go up a little lower than A. So that is B. So this should be okay. Let me draw a dotted line so that we know where that point is located, like this, right? Like this. Okay, how about C? C is 13 and 38. 13 is over here. This is 13, and 38 is going all the way up to 38. So this is 38, right? 38. So the intersection is where the point is located. Okay, D is 15 and 36. 15 is 6, 8, 10, 12. This is 13, right? Wait a minute. 4, 6, 8, 10, 10, 13. Okay. Sorry, this is 14, right? 14. This is 14, not 13. So 13 should be over here. This should be over here. So made a mistake here. Now C is not there. So C should be on the 13th. This is 13, right? 13. So this is point C. Okay, 15 is 14, 15. This is 15, right? 15 and then 16. So 15 is 15 and 36. 15 and 36 is over here. 36. Draw a little grid line so that you can place the graph the point correctly. Okay, the last one is 20 and 37. So 20 is over here and 37 is 36. So between C and D, right? C and D. So over here, 20 and 37. So that is the point for the fifth person. Okay, then we need to label the x-axis and y-axis. The x-axis is the space between seats, right? X-axis is the space. This is the space between seats. So that is in inches, right? Inches. And then the vertical line is the evacuation time. Evacuation time in what? In seconds. Okay, done. So graphing a scatter diagram is really simple. Draw x-axis and y-axis based on the data. If the data contains all the positive value, you don't have to put negative lines. So positive lines. And then if the number is very large, starting from a large number, then you can cut some parts, from the beginning of the line, x-axis or y-axis. Okay, next definition is average rate of change. Okay, average rate of change is, there are 2 points. So using these 2 points, the average rate of change is change in y divided by change in x. So change in y over change in x is, there are 2 points. So the change in y means the distance between, the vertical distance between 2 points. So let's look at this. Here are 2 points, here like that, like this. This is x1, y1. And this is x2, y2. Then the horizontal distance, the vertical distance, this is the change in, this is change in y, and then this is the change in x. So what we do is y2 minus y1. Okay, y2 minus y1 is the change in y, and then change in x is the horizontal distance, x2 minus x1. Okay, so if you start with 2, then this gotta be 2 and 2. Okay, start with 2 and ending with 1. Okay, that's the rate of change. Okay, average rate of change. So example 4. Okay, find the average rate of change per year. So every year, what is the population change? So the average rate of change per year in the U.S. population, number one is exercise 4, from the year 1800 to 1900. So in 1080, so 1800 is the, let's say this is the x coordinate, x values, and then the population is the y values. Okay, so based on the year, the population changes. Okay, so 1800 is the x, and then 5 is the y value. Okay, then in 1900, the x value will be 1900, and then the y value is 76 million. So y values is in million. Okay, 2000, so the order pair for 2000 is x is 2000, y is 281. Okay. So for number one, find the average rate of change from 1800 to 1900. So we have these two values, these two data, right? Two data. So the average rate of change is y2 minus y1 over x2 minus x1. So let's say the second order pair is the this is x, second point is x2 and y2. This is x1, y1, x2, y2. So y2 minus y1. 76 minus 5. 76 minus 5. That is the change in y, right? Change in y. Over change in x is 1900 minus 1800. So 11 over 100. Not 11. 71 over 100. So this is 0.71. 0.71 million. 7.71 million per year. This means per year. Million per year. So that is the average rate of change. So every year, 0.71 million population increased, people increased. Can you see it? So, this is equal to 0.71 over 1 over 1. So the denominator it represent number of years. So over 1 year. So 1 year. So every year there is an increase of 0.71 million. Okay, number 2, same thing. Number 2, let's use number 2 is the population, the average rate of change per year in the population from 1900 to 2000. So 1900, let's say this is x1, x2, and 2000 is the second point. So x1, y1. x1, y1. So the second point is x2, y2, right? So y2 minus y1 over x2 minus x1. This exercise, this is the problem number 4. Okay, this is problem number 4. So y2 is 281 minus 76 over 2000 minus 1900. So the numerator is the number of population. So 281 minus 76 is 205, right? 205 over the bottom is 100. So for 100, there were 205 millions increased. So this is equal to 2.05 million per year. So every year there is an increase of 2.05 million. Okay, that's the average rate of change per year. Okay, we are done for this section.